Good evening, Professor. This is my personal timetable and the research updates. In the last week, I did this research and I found that some there is no response after the immobilization of the polyaniline and the gold nanoparticle. Unfortunately, there is no response because of the sensitivity problem, so I just choose the another one. But today I just went through the again after the ADC NHS. So I found that the value it comes like this much. So there is no positive response yet because of the slightly narrow particles onto the substrate. So I just deny this one, and I'll make the new one. So I just make this one. So before to make the new parameters and the uh, recipe of this research, so I have to do some literature survey before that. So I found that there are so many researchers using the enzyme with the polyaniline layer with using the um, it's mixed together, and then they mobilize onto the surface because this one is like they did the electrochemical measurement, but in our case we have to focus on to the device part. That's why I just move on with this recipe. Not I'm not using that exactly that one, but I just have to because know more about if we use the polyaniline and what is the basic aspect, because our problem is that we don't have the in a previous experiment I didn't get any the like more difference between my the bare one with the using the polyaniline. So I just have to check. That's why I just do some literature review. So here I found that like that researcher used the glucose oxidase with mixed with the polyaniline, and they just using the electrochemical method. But in the other case, they just use the glucose oxidase and mix together with the aniline as well as the gold nanoparticle. So in our case, we have the gold nanoparticle as well as we have the glucose oxidase. So I just might be like I just wanted to try if there is some positive response, then it would be good for us. So that's why I just use that experiment, because our main focus is related with the device. So they use the glucose oxidase mixed with the polyaniline, and then afterwards they mobilize the gold nanoparticle onto that one. So the bonding is stronger between these three composites. And after that, they just use the electrochemical measurement, and the proactive probe is contributing with the glucose oxidase, and to the convert it into the gluconolactone. It turns into the glucose. So this is the basic criteria of this electrochemical method. So and other thing is like they use the gold nanoparticle. They like because they just check the presence and the absence of the gold nanoparticle, how the system works. So they found that they use the gold 20 millimolar glucose and the polyaniline like 200 millimolar, and then they just use the different kind of a size, and they just take the response in terms of the time versus current ratio. So they found that because like there's a specific size of the gold nanoparticle, it occurs in a positive manner. Like if you can see here in the black peak shows the without gold nanoparticle. It means the current is not go through after the zero point 0.4, but after like at the case of 3.5 nanometer gold nanoparticle. So they found that the exactly like the positive feedback from the 3.5, but after the 6 nanometer and the 13 nanometer, the gold nanoparticle is goes down because of the particle size. So the in this graph, because of this graph, I consider that the gold nanoparticle size also matters towards over the reaction. So is the polymerization solution, like they use the optical measurement as well, like they if you can see here the wavelength versus absorption curve. So they found that the second number peak is just having the red shift, and after that without with 6 nanometer gold nanoparticle and with 13 nanometer gold nanoparticle, so they found that the wavelength is changed in each cases. So as per apart from this whole research, I just have to make the one new uh, biosensor recipe to check with our device, because our device is is so much different from this current research, because they did the electrochemical measurement and they used the different kind of electroactive probe as well. So apart from this, so I just make this our new plan. So as it's like we use P6 chip, because P6 chip, the positive factor of P6 chip is like having the large surface area, so it might be, the bonding between these two, so it's going well. And they use the polyaniline, and I just have to mix one new element layer like glucose oxidase and the gold nanoparticle as because we have already that one, and I just add on the MUA, EDCNHS, and our commercial antibody and antigen, is that is the corona one. So there are the several emulation methods, because first one is like entrapment, is like entrap in between these the other metal, other composite. And the cross linker is means like the cross linker are kind of but in our case is like sometime the system works like as a cross linking, because we use the cross linkers, and sometime it works as a adsorption in the case of the uh, it depends on the surface morphology and particle size. If the particle size are like there is a finger in between the particle size, there's some aggregation also, so it might be getting the absorption emulsion methods. So there are the several methods here, and but I'm sure to have this B, because of the cross linking, we are use the cross linker, so the bonding is like looking like this onto our surface. So as I said, I use the P6 chip. So first of all, I have to make the formation of the glucose oxidase with the polyaniline. So I just have that one, the basic constituents like 200 millimolar polyaniline, and mix with 1 milligram per ml glucose oxidase. And this is my first solution. And the second one is like after that make the formation of the glucose oxidase with polyaniline. So I just add on the gold nanoparticle that what we have in our lab. So this is my plan, and already I have started one. So tomorrow I have to continue this part, because I just uh, shut down my system here in this stage. So until I have to wait until dry or like some wetty surface. So tomorrow I just go through the step 5 as well. So it's like if you see here is my plan is like, first of all I have to do the piranha cleaning, and then afterwards mixing of that solution that I already mentioned before, like formation of glucose oxidase with polyaniline. It's already I have just already make it this solution, and it's like 4 microliter onto the surface. And then afterwards I just use the gold nanoparticle, and after the gold nanoparticle I have already immobilized the MUA. And tomorrow I will go through the EDCNHS and antibody, and then the BSA and the antigen. The it's like there is some slightly change here in the published from the published research article, because like here we use the um, glucose oxidase with the gold nanoparticle is like same, but here we use the MUA here, and then afterwards EDCNHS, and of course it's an antibody and antigen. But the difference is like the device, because our device is So like different from the electrochemical method and the criteria, so that is the positive factor. And the second one is like sensitivity. We have to work on that part. So that's why I just make it and check it, like if they works then it would be good for us, and we will go through the same pattern, and with the different kind of antibody and antigen. So it's already on the way. So it takes 3 to 4 days, and in the next meeting I will present with my results and status of this whole scenario. Thank you, sir.